this case, we have two gene expression files, 165 and 166. But currently, it looks like the barcodes there aren't matching. So I've been doing some search replace, swapping out like dots with dashes. I think we talked about this at the last meeting we had with Tim. By the way, don't let me rattle on if things are unclear. If you can't hear me, or if you have questions, feel free to type them in the chat. Or if you guys are able to call in, you might be able to join by audio, using a phone. I also wanted to just mention that Joel's in the room with me. Hello. So he'll be listening in and hopefully learning a little bit about how to do this kind of analysis and use this new plugin. So now that I've made these changes, I think I just want to restart SeatGeek in order to see if I can make those changes take effect.
Can you?
So I'm not going to save this. No.
Can you call them?
I'll quit completely. And then you'll notice using a Mac in order to get the console window open for SeatGeek, I'm just running from terminal, which is going to show me this window where I can see everything that SeatGeek's doing in the background. And signing in through the Flojo Portal account, I should be able to open up SeatGeek. And then I'm going to open up my saved workspace, which is this demo for today. There we go. Then I want to see if I've managed to make the barcodes in the annotation data match with the raw concatenated data. Now I concatenated these two files together so that I can deal with the analysis of both data files simultaneously, hopefully. So if I go to the Workspace tab and look under plugins, you can see we have a long list of plugins released, the latest of which, probably the most exciting of which, is this VDJ Explorer tool, which should allow us to analyze the VDJ information associated with these cells. So I'll choose one of the meta information data files available there and just add it to this tool. Maybe not. Maybe I messed that up. Try one more time. Should be all contig annotations. No, it doesn't want to load now. These two pieces of metadata. We have barcodes which contain this oligo tag along with a -1. I'm not sure why that's added, probably by Cell Ranger, but that means to match the raw data. And I can open up one of those gene expression files here, maybe 165, in something like a text editor. And we can see that indeed there are things that say -1 within the gene expression data. Oh, I see, but this is not the concatenated file. Let me open up the concatenated file. So there's our concatenated data file. So this is a combination of both files 166 and 165. And if I open them up in a text editor, so I can see that each of those barcodes have an oligo tag followed by .1. So we need that to match what's in our metadata file. So I'm going to go ahead and change that back to dots. And that's really, really simple. We're just going to do a search replace for that character. So let me close this down. And now we're looking for dashes, and we're going to change that into dots. I'll try that out with a couple of these. Looks like it's changing them fine, so I'll replace all. And then go ahead and save this all contig annotation file once it's finished, with the search replace process. Any questions on that so far? So substituting any dashes that we find with.
No, you're. The problem is you gotta turn the volume down. Somehow, see, he's coming from here. Or turn the volume. I'll mute this way. Then we'll just use that one for the audio. All right, should work now. This is muted. See, he's coming in both ways. So now just. Well, it's coming through some other place, like up there. Turn that off. You don't need that. Yeah.
So we turn that off.
Right, because that's doing it too.
Right.
You're getting two audios here. No. Leave this on.
If you guys can hear me, probably you have
Just,
two machines.
right.
Now we turn off the other one. So can you hear us now?
You can turn it up.
Can you hear us now?
Yep, I hear you.
Yeah, you can turn it. No, don't mute that one. You need that mic. Unmute it.
Yeah, but it's here.
Oh, okay. Oh, that's something. Okay. So Ian, can you hear us now?
Yep, I do.
Okay, so we'll get the audio over here, and I'll continue to look at the video on the big screen. I want to see if I can turn you up a little bit. Now it's too low. There's the, somewhere over here is the audio. I mean, you were too loud, now it's just too soft. Let me see. The audio thing is, there's a microphone, but that's not going to help. Because you just...
It's down somewhere nowhere.
Oh, I know. One problem is, you got to close the window and look at the thing. It's underneath somewhere. Is this a window? No. Right.
So, and you guys are all set.
Yeah, I think so.
Just we
Okay, cool.
want to turn the volume louder, but somehow we can't because we want to hear you better.
Is it okay?
Yeah, as long as all the other machines in the room are muted,
Yeah, they are.
or have their volume. Okay, so you guys should be able to turn up the volume on this machine probably. I know you guys were getting bad feedback before.
Right now we can turn it up on this machine. You gotta minimize something.
But if we're all set, then I'll continue on. Kind of, some of this will probably be repeat from the last time we talked, but always good to get a review, I think.
Do you mind if I record the audio?
So, the next thing I would want to do in this data, starting to get into like clustering, in order to have something to compare in the VDJ Explorer. I'm going to go ahead and run quality control, and these are concatenated data files, just using the two that you have contiguous annotations for, 165 and 166. By the way, do I remember correctly that these are coming from different patients?
Right, 165 and 166 are from two different patients.
Oh, I think you might have gotten muted again somehow.
You hear that now?
So, what I'm doing here is just drawing a quality control gate within the quality control window for cell view. So you can see we're in cell view here. And that creates a new population back in the workspace that contains most of the data that we had in that concatenated data file. And I'm just going to close down that window. Now in the gene view quality control, I'm going to gate to remove outlier genes or outlier parameters from this data set. So we typically like to look at total reads versus cells.
IRF 379.
Right, interference response factor. So any IRF, but
IRF, sorry.
IRF 3, 7, and 9.
Right.
So that's a pretty good gene set. We can.
Any interferon, type 1 interferon, IFNA,
Yeah, IFNA something.
any of them.
Any of these?
Any, yeah. I mean, anything that's IFNA. Right, you get them all. Yes,
Was there more? Sorry.
I can't read the lower ones there.
Right. Can't see it well.
I can't see it, but I don't know. IF. There's IFN alpha 2.
Right, we want, any of the IF.
I think any of those IF. Are those IF? I can't quite see it on this computer.
Yeah, so these are all under the filter IFN. but then there's IFN-AR2, IFN-GR2. Did you say anything with IFN?
Yeah, I think so for now.
One of the, there's an IFNA2.
Oh, here's 17.
Right.
That's a higher abundant one. So any of those for now.
Right, any of those.
Let's try that. What we really, this would be great.
Right.
And then identify those cells. This is what we want. Identify those.
So now there's a couple of choices we would make, and I'll just try it out and show you what I'm thinking. You can look for cells that are expressing any of these genes by choosing this gene set and looking at the sum of expression for those 32 genes.
Right.
And then it looks like it might look better on a log axis.
Right.
So that's what I've switched to. And now I could gate on anything expressing more than one IFN. And that's a huge amount of data, actually. Looks like 71% of the data has some IFN expression.
Oh, wow, that's good. That's interesting. I wonder which one it is. I mean, one of them is in abundant. Is there a way to show which one of those genes is most contributing to the most of that?
It's a good question. A couple of different ways you could look at that. One might be to just scroll through these different genes. Right?
Oh, yeah.
Just plot each one.
So which one was it? IFN?
Alternatively,
what would be great before we get disconnected or something? Can you send this data set and this maybe even your workspace and all that? Your current.
Of course.
Because we don't have
Yeah, of course, absolutely.
We don't have a sort of a merged data set for anything. For anything. Okay.
Yeah, and it's real simple in SeatGeek to create a merged data file, right? You just, I can kind of show you what I did. I will, of course, send you any of these artifacts. Actually, we're really grateful for your guys' willingness to share the data, allow us to look at it to help to develop our BDJ Explorer plugin.
Oh, yeah.
We would always be willing to help out like that, but especially grateful to you guys. So let's see. New workspace. I'm just going to add the two expression files that we're dealing with in this case, the 165 gene expression file and 166.
What about the VDJ?
So we haven't got into the VDJ stuff yet at all. But you just mentioned that you didn't have any combined data files.
Okay, well that's the first step, right?
Right. So if you right-click on a selected set of populations or samples, you can choose Export Concatenate. It opens up this window.
Yeah.
And if you concatenate, then you can combine all of the genes for all of the cells into one data file. That's all that I did.
Is it going to remember? Is it going to be 165, 166?
It's not going to remember, except that it's going to contain a sample ID parameter, which I'll show you next. So this is just to give you an idea of how to export. So now if I go back to this combined file, I can actually just reopen our graph window here. I'll duplicate that again. And if you look at a histogram of sample ID, this parameter distinguishes between the two samples that we combined. And so then from there I can kind of infer which one came from which sample.
Oh, okay. See, what would be, but of course, would be important is if one's a normal, or, well, like one compared to the other, but on the same kind of plot,
Right. So, yeah, we should really get to that. I mean, that's a really interesting set of features within SeatGeek, right?
Yeah.
So, haven't quite made it through quality control.
Right. Okay, I got you sidetracked, but that's good. If you that list, one thing, the quality control or not,
Right.
getting that list of cells. The more important thing to us isn't the quality control cells. I guess that's something, but the list of genes that express, or list of cells that express interferon-related genes, that kind of thing. And you can see if we look at any one.
Absolutely, and then especially looking at like unbiased clusters, you can determine where are the cells clustering relative to expression values.
And what is dispersion? What does dispersion mean here?
Yeah, so it's related to variance, and we find in practice that the more variable a gene is, the more likely it is to describe a biologically significant population. And so, again, this is all just drilling down to a set of genes that I want to use for dimensionality reduction and then clustering.
I mean, it seems as though you're eliminating a lot of, or you're capturing just a few cells that, these
aren't cells, these are genes.
Oh, genes, right. Oh, the meeting is ended because host didn't show up. What's this? Okay.